Hi, everybody. I'm Wave 3 News Chief Meteorologist Kevin Harnett. We've got part of our team assembled today, and we're joined by Brian Schopmer from the National Weather Service in Louisville. Brian, we appreciate your time today.
Thanks for having us on.
Yeah, we're going to keep this laid back. I see we've got several hundred people in, and they're just kind of kicked back on this rainy Wednesday. We've been doing this all month long where we said we'd spend part of our, working at home to help sort of school kids at home. This will be a little bit different today because this is really meant for all ages, and this will be a spotter training session. I know you guys have been impacted as well as us by what's happening in the world, and typically through this time, which is storm season, you all would be out and about kind of training people and giving a heads up of what to expect on how to spot storms. So today we wanted to jump in and see if we could team up, and I'm glad you all said yes, and I think this is a good opportunity for not only all of us, but for people at home too.
Yeah, we're happy to do it. And like you said, one of the more enjoyable things we get to do every spring is go out to the communities and teach the spotter training. And yeah, with the pandemic, we had to cancel a lot of those classes. So this is a perfect opportunity to reach out to everybody and teach them a little bit about weather and storm spotting. So.
Yeah, let's jump around. Of course, folks that are on may recognize our team. I'm Kevin Harnett. And I went to Purdue, and weather has been a passion since I was a kid, and I grew up just south of here in Nelson County, so this is home to me, and I'm glad to be here, and I know that's what we pride ourselves in on our team, is sort of being hometown folks. So many of us are from here. Brian and Tawana, Lauren and Andy, the rest of our team couldn't be with us today, but Ryan Hoke is with us, and he's a hometown guy too.
Yeah. I was actually born in the Nashville area, but after 2 weeks of being born, moved right here to Louisville. I've been here in Louisville basically my entire life. Grew up watching Wave 3 News, loving weather. Went to Mississippi State University to get my degree in meteorology, and here I am. And of course, we have Mr. Justin Logan, who was raised just down the street from us.
Yeah, just down the road over in Paris, Kentucky. If you don't know where that is, that's near Lexington. Grew up there, went to Western Kentucky University to get my meteorology degree, and been back at Wave since fall of 2018. Glad to be here. Love Kentucky. It's my home.
Yeah, and Brian, obviously, we want to say a big thank you to you. Tell us sort of a little bit about your background. You work with the National Weather Service. I've had a chance to know you for many years, and just give folks at home a little bit more about you.
Yeah, Brian Schopmer here, National Weather Service, Louisville. Grew up in southeastern Indiana, Greensburg. It's a little town there right between Indianapolis and Cincinnati on Interstate 74. And went to Ball State University to get my meteorology degree on the other side of the state from where Kevin went. And then after that, went to National Weather Service Jackson for 3 years. So that was in eastern Kentucky. And then I've been in Louisville now for 10 years. So spent pretty much all my adult life in the Ohio River Valley, and certainly know the challenges that come with forecasting the weather here, but love every minute of it.
Yeah, it's why I have a lot less hair than when I started.
I got a few gray hairs with weather on it. So.
All right, well, enough about us. Let's get started. Brian's going to lead us through the spotter training as they typically would if we were at one of the events that they host typically. So, Brian, we'll let you take it away. I'll remind folks that as we get started here, there will be a chance to ask some questions toward the end. So this is the severe weather spotting training sort of class, if you will. So kids at home are really going to learn a lot, but this is for adults as well. And as we get started here, your questions, we'll take those toward the end. So we'll begin by saying thank you to the National Weather Service, and obviously we work in partnership with you guys every day, Brian.
Yeah, we sure do, and thanks to you guys again for having us on. This is a great opportunity to reach out to everyone and teach them a little bit about weather while there's a little bit of weather going on outside. So, normally our spotter talk is 2 hours long, and we don't have that much time today, so we kind of condensed it down. But the main part of this presentation is going to be about storm types, what type of hazards to expect with those storms, and then a lot of cloud identification, certain features to look for with different types of storms. And then we'll follow that up at the end with a little bit of storm safety. But before we get to that, I just want to give you a little bit of an overview of what the Weather Service does and some tools that we use So we are the National Weather Service. We're under the Department of Commerce and National Oceanic and Atmospheric Association. And our job is to provide weather, water, and climate data in addition to providing forecasts and warnings. So when I say warnings, I'm talking severe thunderstorm warnings, tornado warnings. If you're in the wintertime, we're talking winter storm warnings, winter weather advisories, those things that get the youngsters out of school there. So, that's our job. There's 22 of us here at the office here in Louisville. Most of us are meteorologists. And you may be asking yourself, okay, we have an office in Louisville. Where are the rest of them? Well, they're all over the country. There's 122 offices throughout the country. And if you look at Kentucky, there's actually 5 different offices that serve our area. The Louisville market is pretty close to Wave 3's TV market. We have a good chunk of southern Indiana and then all of central Kentucky. And then if you look at Indiana, there's actually 6 different offices that serve that area. So, and we're there 24/7, 365 days a year, keeping an eye on the weather for you all.
And, Brian, I'll add that because a lot of people think, now, do you all just get the forecast from the Weather Service and put it on TV? We get to ask that question all the time. And the answer to that for folks that are watching is no. We actually, we obviously look at, the data that you all have and provide. But the way it works is we work in tandem with one another in getting that information out. Sometimes we may agree with the forecast so it looks similar, but our team, much like the 22 that you have in your building as meteorologists, all of our team are meteorologists. We all have similar degrees and are able to do the same thing, just for clarification there.
Yeah, and you're right. And it is a good teamwork, good partnership, and we all have our own roles to play in this. So, that's good to clarify that. So moving on to the next slide. So there are basically every office has a radar with it. It's a Doppler radar. It's called the WSR-88D, and they actually have the ability to see not only the rain, the snow, sleet, hail, but motion within the storm. So basically it measures how fast raindrops are moving toward or away from the radar, and that's what it is able to help us see rotation in storms and maybe have an idea of how strong the winds are with storms. I wanted to give you a little bit of history about radar. It's kind of interesting. Radar, how it came to be, it actually goes back to the years leading up to World War II and in World War II. Military actually used them initially for, basically they wanted to know if enemy planes were approaching to give a heads up. Obviously you want to know if they're coming at you. So, but what they noticed was that there were weird echoes on the radar that weren't associated with planes, and they learned that it was actually, precipitation, rain, snow. And so the folks then remembered that after the war was over, and they developed radars, more catered specifically to weather radar. So, the 50s, 60s, 70s, and early 80s, the radar did not have the Doppler component. And then late 80s, the technology was developed, and then by the mid 90s, they implemented it to where we actually had the Doppler component. And then now about 7 or 8 years ago, we got dual polarization, which also gives us kind of a 3D look at the raindrops, and also helps us see other things like storm debris. So
and that really transformed the way we do weather, especially with warning lead time, giving people that advanced warning of sort of seeking shelter from dangerous weather.
Yeah, because if you can see the rotation in storm, then you can actually try to get lead time on tornadoes, whereas in the past, when you couldn't see the motion in the storm, they had to wait to see that hook feature, in the radar echoes, which we'll talk a little bit more about in a minute. And by that time, you may already have a tornado on the ground. So yeah, it's advanced our knowledge quite a bit of tornadic features and other features within storms.
And frankly, it's how we begin that warning process.
Exactly. Yeah. So you may be wondering, just real quick, how the radar works. It sends beams of energy out, and when they bounce off raindrops or hailstones or even birds and insects, sometimes we can see birds and insects on radar, it scatters that energy back, and basically then the radar, if there was a lot of raindrops, it'll scatter quite a bit of rain or energy back, and then that paints a picture on our screens, and we can kind of interrogate storms, and we can look at several different levels of a storm. So we can see hail forming aloft before it even hits the ground a lot of times. So that helps us get advanced warning in that situation. Now, one thing to keep in mind, radar does have its limitations. After you get about 70, 80 miles out, you start to be able to lose the ability to see below the storm. The beam is actually rising the further away it gets. One, because the Earth is curved, and two, because the lowest tilt is a half degree off the ground. So the further away you get, we don't have as much ground truth, and that's really why we need spotters out there. So I think we can advance to the next slide. And so we kind of talked about how radar can help us, issue warnings and stuff, and we talked about the partnership we have. So I just real quick, we hear us talk about warnings. You've probably heard us talk about watches too. And the idea is that the watch comes first. So that's basically your get ready time frame. That means that the conditions are favorable for severe weather or tornadic activity. If you're baking, you have a recipe, you have all your ingredients set out on the counter, but you haven't put them together yet. So the watch is ideally it's issued before the storms even fire up. And then once we get the storms to fire up and they start becoming severe, that's when we go into action, and that's when you see you all on TV, communicating very well, the threats, the timing, and that's really how the partnership works. You see in the picture of our operations area up there, and we're constantly sending information back to you guys, and you guys are sending information back to us. You guys get reports from viewers, which helps us a ton. Because if you take an example, like say we think this storm has a quarter-sized hail in it, and we get a report and they said, oh no, that was ping pong ball-sized hail. We're like, okay, well we can apply that to the next storm and put out the proper information. So those reports really help us out to know what's happening in real time.
I think it's so important to let people that are watching know that through the severe weather process, each day, in fact, in front of me right now is a screen that I can see and communicate with the National Weather Service, even here at home. So in our office, in our homes, we have a direct connect with you guys at the Weather Service, and that goes both ways. And all TV stations have that, and ham radio operators and school superintendents and all of that thing. So there is really a direct connect in that way. Many times in severe weather, Ryan is running our social media.
Yep.
And Ryan, speak to that part of, because this whole thing is about the spotter process, what we need from you folks sitting at home. And as we go throughout the next half hour, you're going to see things to look at and look for when severe weather is happening. Now, we're sort of starting with assuming that it's already underway, what we need from you. And so many of those reports are helpful, as Brian mentioned there, as far as from our viewers.
We can have all those sort of radar technology that is possible in this day and age, but at the end of the day, some of our best technology is phones. We're getting reports submitted from viewers, from spotters, from ham radio operators through Twitter, through Facebook, to our social media platforms, and then we relay that back to the National Weather Service. Gone are the days in the late 90s when there was like a Yahoo or AOL chat group where you would communicate with the National Weather Service. We now have this centralized National Weather Service chat that we have a direct line of communication to the folks who are issuing the warnings. Oftentimes, when we don't have enough radar data for the National Weather Service to issue a warning, it will be a spotter report that triggers it, because it's like, whoa, we've got a hail size. Whoa, we've got a wind criteria that has been met here, or a funnel cloud has been spotted. So that eyes on the ground, that ground truth, just through simple communication, is probably one of the most important things that we do as broadcasters in weather, but also one of the most important things, I'm sure for you guys, Brian, that you get from us and from folks in the general public too.
Yeah, and it's important to mention too that in that chat room, there's emergency managers in there, so they know what to expect, because they've got to watch out for their counties. So it's really kind of a triangle between the Weather Service, the media, and emergency managers, working together as a team, like we said. So it really works well.
Yeah, well, we appreciate being a part of the partnership. Let's jump into the meat of what we're talking about today, and that begins with a thunderstorm even beginning and what it takes to continue to grow. So this is the thunderstorm life cycle.
Yeah, and so there's 3 stages to it. The first stage is the updraft stage, or the developing stage. And what's happening basically is your air parcels, when they heat up at the ground on a hot and moist day, they'll start to rise. Think about a hot air balloon, right? You heat up the balloon and it rises, and if you let some of that heat out, then you'll start to sink. Well, that's what's happening to these air parcels. And so, what we know is, an air parcel that is warmer than its surroundings is going to continue to rise. So when you think about when you go up in height, the air cools with height, right? That's why we still have snow on top of the Rocky Mountains in May. So that air parcel just keeps rising and rising and rising, and until basically it gets to a layer in the atmosphere about 50,000 feet up in the air called the tropopause. Now, what that is it's a warm layer between our atmosphere down here in the troposphere and the stratosphere, which is the next layer up in the atmosphere. And that, when it hits that warm air, that air parcel can't rise anymore. And so if you think about a balloon, you let it go in your house and it rises up till it hits the ceiling, then it stops. That's exactly what's happening with a thunderstorm. And so you have all this momentum and energy, and it hits the ceiling, and then it spreads out across the top of the sky. And you see the anvil-type cloud that you see there on the middle stage. And then actually sometimes the updraft is even strong enough that it'll punch into that upper layer a little bit, and you get what we call an overshooting top. So if you see an overshooting top on top of a thunderstorm, then you have a really strong updraft. Some other indicators of a really strong updraft are, if you look at the picture in the lower left-hand corner, you see how knuckly and it looks like almost like broccoli or cauliflower. If the cloud looks like that, then it's a really strong updraft. Sometimes the speeds can reach up to 100 mile an hour, which is what helps keep hailstones aloft.
Just very and almost like bubbling up in a way.
Yeah, exactly. And if you watch a cloud like that, you can actually see it rise if you can stare at it long enough. So that's definitely why airplanes avoid thunderstorms at all costs, because it would be a bumpy ride if you got in the middle of that. So the second stage is then the mature stage. So once basically those those air parcels will then cool and condense, and they'll start to produce rain. And the moment they produce rain, that's when it becomes a cumulonimbus. And I know last week on your Weather Wednesday, you all talked about cumulonimbus clouds. And this is the point of the storm's life cycle, where it's going to start producing rain, it's going to start producing maybe some lightning, maybe some hail, and gusty winds at the surface, because you get a downdraft when that rain cool air starts to sink. And so then the third stage is basically when the thunderstorm loses its updraft and it becomes nothing but a downdraft. And so then all that rain just rains out and the thunderstorm goes away.
All right, so that's the life cycle. We can have multiple cells or single cell thunderstorms. Some of these single cell thunderstorms we typically think of in the summertime. We heat the ground, that air rises. We develop what we would call a popcorn thunderstorm or something of the sort.
Yeah, and these are the most common type of storms, especially in the summertime. Those are the days where we say it's a 20% chance of rain and it starts out sunny, and then suddenly in the afternoon you get a storm that pops up. And most of these are pretty tame, tame for a storm anyway. You get, some hail, maybe small hail, lightning, a few strikes here and there, brief heavy rain. It's only the strongest ones that are actually going to produce severe weather, where we're talking about, larger hail and stronger winds. Really what drives these thunderstorms is the updraft. And when you get in the middle of the summer, what we know is that the jet stream is usually displaced well to the north. So you don't have any vertical wind shear. So what happens is that updraft goes up, and it goes straight up. And then once it starts to rain, the rain falls right back down on that updraft. And I think if you advance the slide, it'll kind of show an example. Yeah, and it basically chokes off that updraft really quickly. So that's why we call these pulse storms. They go up real quick, and then they just kind of disappear and fade out because there's no vertical wind shear. And I wanted to just touch on real quick, because we talk about severe, we've said it a couple times, what actually characterizes a severe storm. It's 1 inch hail. So anything that's the size of a quarter or larger, because a quarter is basically 1 inch in diameter, is considered severe hail. Back when I started in the Weather Service, it was actually penny-sized hail. So they actually raised the criteria because they realized that penny-sized hail really doesn't do any damage. Now, when you start talking about golf balls and baseball-sized hail, that's when you're talking about some serious damage and a serious updraft to go along with that storm. So that's kind of what we're looking for. And we ask people, if you report hail, please don't report hail the size of a marble, just because there's several different sizes of a marble, and we don't really know what that exactly means. So try to compare it to a coin if you can. That really helps us out.
Yeah, sometimes we'll get the pea size, the marble size, but it really is, if you stick to the coin theory, then everybody knows the size of a dime and a nickel and a quarter and a $50. And then once it starts to get higher than that, then you're really talking about some damaging hail, and that's when you get the ping pong ball, golf ball, baseball size hail. And we've had these sizes around here before. We've had baseball size hail a number of times. in our viewing area over the last, well, at least the last 21 years that I've been here.
And something that should be underscored with the larger hail is that you should not be out in it. So many folks want to go out and take pictures of this hail, try to experience it. The terminal velocity or the maximum speed of some of these larger, heavier hailstones is enough to cause fatal injury. So don't be outside when there's hail falling, especially when it's large hail.
Yeah, you wouldn't want somebody throwing a bunch of baseballs at you. That's for sure. So, and it's really no different. And the thing you got to keep in mind too is that if you have hail that big, a lot of times it's wind driven. So you got the wind really pushing it along. So yeah, it can be dangerous for sure.
Yeah. No question. So you mentioned the one part of severe hail over 1 inch, at or above 1 inch, quarter size severe, and winds at or above 58 miles an hour.
Yeah, that's correct. And what it's same as 50 knots, and that's strong enough to drop some trees, things like that. Once you get above 70 and 80, then you can start to get some serious damage. But yeah, 58 mile an hour is the criteria for severe wind. And with those single cell thunderstorms that we talked about, one thing that you can get is called a microburst. And again, we talked about that downdraft where that rain cooled air really starts to drag down towards the surface, and it comes down with a lot of momentum, depending on how strong that updraft was. And so if you think about a garden hose, right, if you're standing on concrete and you let that water come out of the garden hose, when that water hits the ground, it spreads out. And that's exactly what happens with a microburst. All that energy basically hits the ground and it spreads out, and you can get severe straight line winds as that occurs. And one of the things we look for is we look for the rain shaft coming out of the storm, but then when that spreads out, you get a feature called a rain foot. Looks like the shoe of an elf. And that's indicative of really strong winds at the surface. So if you see something like that, we want to know about it. However, you can get that information to us. So those are some things to look for, at least with the single cell thunderstorms.
And these are incredibly dangerous for aircraft, too. Any sort of wind shear event, any sort of microburst, macroburst, that is bad news. Back in the 80s, of course, many famous incidents occurred that caused airports to now have wind shear warning systems for this very type of event here, Brian.
Yeah, there was a landmark aircraft accident that happened at Dallas-Fort Worth that kind of opened everybody's eyes to microburst. It got the plane when it was in landing phase, and the downdraft was so strong that plane could not overcome that downdraft, and they actually hit the ground before they hit the runway, and caused some injuries and fatalities. And we learned a lot from that, and it kind of advanced the science really since then. So. Sometimes good things do come out of tragedy in that sense.
Yeah, we see microbursts around here. Sometimes they're harder to tell. We've kind of flag them with that straight line wind damage that sometimes comes out of them if the storm doesn't necessarily always, flag severe. But we don't always have just single cell thunderstorms. We also have clusters of thunderstorms or linear thunderstorms, which would be like a squall line. So let's talk about the multi-cell thunderstorm.
Yeah. So differing from the single cells usually don't have much of a trigger. They usually kind of just pop up with the heat of the day. The multi-cells, usually there's some sort of larger feature that forces these storms. I know you guys talked about cold fronts last week on Weather Wednesday, and a lot of times with the multi-cells, you're going to have some sort of cold front that's driving these storms. Last night, actually, out to our west, there was a big squall line of storms, and luckily it didn't survive into our area. But yeah, there's certainly plenty of warnings to go along with that. And so, again, these are more of a moderate threat. You'll get pretty widespread rainfall, a lot of lightning, gusty winds, and pockets of severe damaging winds. Basically you're looking at a feature that can stretch hundreds and hundreds of miles across your horizon. And there's a feature, go back just for a second, Ryan. There's a feature on these clouds I want to show everybody real quick. The leading edge of these a lot of times have what we call a shelf cloud. And we're going to show you several examples as we go through this. But basically, when you see this shelf cloud coming at you, that's going to be your indicator that, hey, it's about to get windy, it's about to get rainy, and the lightning is also going to follow. So just wanted to show you guys that, and then we'll touch on that more in a little bit. But yeah, these cover the horizon, and a lot of times it's mostly just 50 to 60 mile an hour winds, a lot of rain, lightning. But there are portions of this storm that that we're looking for more intense winds, and that's when we get to what we call bowing segments. If we can go to the next slide. So yeah, what we're looking for, and the difference too with multi-cells is you usually have wind shear aloft. So what do I mean by that? That means increasing wind speeds with height. And what happens is we get these lines of storms, and you'll get what we call a rear inflow jet, or a really strong jet of wind that comes into the back of these storms, and it causes them to bow out. It's exactly like what you see on the screen there. It looks like a bow and arrow. And so your strongest winds are going to be right at the apex or the point of that bow. And, if you see, I know you've seen you guys on TV talking about this all the time, this storm's starting to bow out. Okay, this is one we really have to watch. And what happens also is just north of the bow, a lot of times we can get a little spin-up tornado. We call them bookend vortices on the north end. And if you think about a truck driving down the road on, say, a snowy day, and think about that energy that's pushing through, and then you'll see a little spin-up of a snow swirl on the north side of that truck. That's what's happening here. It's so much energy pushing into the back of that storm that it causes a little spin-up on the north side of it. So there is a tornado threat with squall lines, multi-cells. The main threat is, the damaging winds and the rain and the lightning. But yeah, you can get brief spin-up tornadoes with these, and so we have to keep an eye on those.
And so, what the radar would look like depending on where you're located. So let's talk about kind of the field of vision here.
Yeah. So yeah, when we get enough of these, we kind of wanted to show you what you're looking at, as these approach you. And like you said, these are hundreds of miles long, so they're going to cover your whole horizon as they're approaching. And so I just want you to pretend that you're, with this little white dot here on the screen, and you're looking, to the northwest at this storm approaching you. And so what do you think you're going to see? Let's go to the next slide. Well, the answer is that we live in Kentucky and Indiana, and we have plenty of hills and trees. So you may not see anything at all. And I know you all are laughing at my cartoon trees and hills here, but my art teacher, I'm sure, is proud of that. It took me like an hour to make the slide, so I'm proud of it.
Nice. It's like a Christmas tree field. I like it.
I like it.
Christmas come early. So, but no, so yeah, we just kind of tell people, you see storm chasers out in the plains chasing storms, and, they have flat, areas. They can see miles and miles, but we really don't encourage people to chase storms around here because it can be dangerous. Instead, if you're spotting, what we kind of encourage you to do is find a high point somewhere that you have a good vantage point and watch that storm come to you, because we don't need to be driving around on hilly, curvy roads with storms bearing down on you. The other thing is you don't know what's coming at you if you can't see over a hill. So the other thing I kind of wanted to call your attention to is watch out for false horizons. The terrain that we have here can kind of create false horizons. You think you see something that's on the horizon when really it's not. Think about like a storm off in your distance, and if there's a line of trees between you and that storm, and you see, say, a low-hanging cloud hanging down, you think, oh no, that's a tornado, that's touching down. The reality is it may not be until you get on the other side of the trees. And so this example here we're showing you, it looks like it could be a tornado, and in reality it's just kind of a low-hanging cloud. So, if you see something like that, just watch it for a second. If it's tornadic, it's going to be rotating. And also watch the ground below it. If you see like a funnel coming down, watch the ground below it, because it's going to start to pick up debris on the ground a lot of times before that funnel even reaches the ground. So, and this is a great example of a shelf cloud. So we showed you one example earlier. This is another one. Again, it's a feature that just stretches across the whole sky. It looks ominous, and really it is ominous because it signals the arrival of what could be severe weather. At the very least, it signals gusty winds and heavy rain. Here's another example from out in Nebraska, and really they can be quite spectacular. These are really beautiful in a way. And so, the stronger ones, they can produce 70 or even 80-mile-an-hour winds if you get a really good one going.
Over the last few years, we've had several spectacular shelf clouds move through our area, too. The photos, of course, now everybody has a camera in their phone, so we're getting more and more pictures of them. But they really have been spectacular over the last few years, even around here.
Yeah. I'll tell you what, we enjoy the photos too. So people are really good about sending photos, and because we're in the office, we're looking at radar, we grew up loving weather, right? And so we kind of like to see these things too, but sometimes we can't because we're in the office watching. So we love seeing the photos. So send as many of those as you can safely. Make sure that you're safe when you're doing it. But yeah, definitely love to see them. So
let's talk about what to look for. Let's go back to that slide so we can talk just through it one more time. How do you tell if you're looking at a squall line?
Yeah, so that the shelf cloud approaches you. It's going to cover your whole horizon And again, what it is it's actually, it hangs lower because it's the interface between your updraft and your downdraft. Again, that downdraft is where your winds and rain come in. And so it creates this kind of like, almost like a little lip that hangs down on the front of a storm. So, and it'll come at you pretty quick. A lot of times these things move at a pretty good pace. So, if it looks like it's on the horizon, you say, oh, I got, 10 minutes or whatever. That may not be the case. It may get there pretty quick, especially if it bows out. And, just keep in mind the main threat is wind damage, but you can get brief little spin-ups of tornadoes inside of those. So,
and those are some of the hardest tornadoes to pick out on radar, those QLCS tornadoes, as we call them, quasi-linear convective system, big old squall line moving through, a little kink in that on radar, and you get that quick spin-up tornado. I know when I was doing some radar simulation training with you guys at the Weather Service office, one of the case studies that you had the participants do was a QLCS tornado scenario in January of a given year. And man, those are tough. And for those folks at the Weather Service office there that have to pull the trigger on issuing tornado warnings for these storms, that can be a lot of sweat on your brow.
Yeah, that's a good point, because there's several reasons. Number one is they're lower level circulations, so a lot of times we don't see them as much as, the ones that are in the mid levels. The other thing is, like you said, they spin up really quick, so they are hard to catch, and that's why we try to message a lot of times that sometimes in our severe thunderstorm warnings we'll put tornado possible, because what we don't want to do is we don't want to false alarm and try to hit we try to hit every one, but we don't want to overdo it, because we get a lot of those signatures that don't produce. So we try to say, hey, there's a brief tornado possible within these storms. So yeah, it's a good point to bring up how hard those are to warn on sometimes and how quick they come and go. So yeah, those are multi-cells. We covered the first two. Now the third one is the Supercell Thunderstorm, and this is the one, this is the granddaddy of all thunderstorms. And there's something that makes this storm different and unique from the other storms. Okay, so we talked about wind shear, right? We talked about that increasing wind speed with height. Well, there's a third component that creates a thunderstorm, and it's called, it's basically because the winds turn with height, they veer with height. And so what that does is that creates a rotating updraft. And if you remember how we talked about single cells and how that updraft goes straight up and then comes down, well, the difference with supercells is that updraft actually tilts. And so when it starts to produce rain and that downdraft, it falls away from the updraft. And that storm is able to sustain itself for quite a while. We've seen supercells last for 3-4 hours, whereas, a single cell thunderstorm is going to last, 10 to 20 minutes. If you remember, well, you may or may not know, there was a tri-state tornado back in the 1920s that covered the Missouri Boot Heel through Illinois and went into southwest Indiana. It was on the ground for 3 or 4 hours and produced violent tornado damage almost over its whole path. That was probably one of the greatest, supercells that we know of, in modern times. But yeah, all severe weather modes are possible with a supercell. Not just hail, but large hail a lot of times. And obviously tornadoes, including strong to violent tornadoes, strong downdraft winds, and prolific lightning. A lot of times these things are just going to just turn out lightning almost constantly. And go ahead.
Well, I was sorry to jump in, Brian, but I was just going to say, and the real feature about supercells is that's the only storm around for most parts. So it's using the energy of the whole environment surrounding it. And there's nothing to sort of bog it down from exploding into this singular storm that would become super impressive or a supercell.
Yeah, that's a good point, Kevin. We talked about the multi-cells, and they're competing for that energy, right? Because there's several different updrafts, whereas, like you said, the supercell, and it almost creates its own environment once it really gets going. And like you said, it's able to draw all that energy all to itself. And so they can really just become intense. And, you've seen the hook echo. You guys talk about hook echoes when you're on live, and, it's really kind of interesting to think about why that radar shape takes form. So what happens is the updraft of the storm is actually, on that reflectivity example, it's actually down there where there's not the bright oranges and reds. It's kind of in that clear air right by where the hook is. But since that updraft is rotating, what's happening is it's pulling that precipitation back around the backside of it. And so, again, a hook feature is something that was just noticed one day and been like, oh, okay, when we get hook features, we've seen that we've had tornadoes with those. And so it's just kind of a lucky a lucky thing that happens that we see this hook develop. And so I just always think that's kind of interesting. And, you hear people talk about, well, it got kind of calm right before the tornado hit. And if you look at how this supercell, looks, it makes sense, right? Because if that's moving, say, from the southwest to the northeast, at first you get the heavy rain, the hail, and the wind, right? And then it gets quiet because you move into that area where there's the updraft and there's not a whole lot of precipitation. And then, boom, the tornado hits. So it makes sense why people say that. And also, the sky being green or whatever, you get big hail with supercells. So, and hail a lot of times turns the sky kind of like a turquoise color. I've seen it. I went out chasing when I was in college, and, you get that green hue, just like people talk about. So there are some truths to things like that.
Yeah, and then you mentioned the lightning, but that's one thing that you've got to be careful if you're in that storm. Lightning can strike miles away because it can come from the anvil top of that storm, and that precedes miles ahead of the storm itself. So just be careful if there's a supercell around, which can, by the way, form in front of the linear storm or the multi-cells, and or a squall line, and those are just simply dangerous when it comes to lightning, hail, rain, possibility of tornadoes. It's the real deal.
And Kevin, sometimes these supercells can also be embedded within clusters of storms. You may remember March 2nd of 2012. That was not a clean supercell situation. Those supercells were kind of clustered together, and we see that a lot in the Ohio Valley as opposed to out in the plains, where a lot of the time those supercells can be more individualized on radar, kind of a cleaner look out there.
Yeah, let's talk about March 2nd.
That's a good point, yeah. So March 2nd, that's and obviously violent tornadoes are possible with supercells, and that's the last violent tornado we had. When we talk about violent tornadoes, we're talking the EF4s and the EF5s. All tornadoes are strong, but, once you get up in that 3, 4, 5 range, you're talking about some catastrophic damage. And, this is one that lives all in, our memories, very well. And, just, these are once or twice in a career type of events a lot of times. And so I kind of wanted you guys about your experience that day and what you remember about it. And I can share my story too if you want. But
yeah, well, first of all, Justin, where were you when March 2nd was taking place? Because
I was living in Georgia, working in Columbus, Georgia at the station. I just remember looking at the data that day and just knew that it was going to be a day that there was probably going to be long track tornadoes. And my church back home, the youth group was supposed to be taking a trip that day. And they asked if I thought that they should be traveling. And first thing I said was absolutely not, because, you want to be obviously in a place where you know that you can seek shelter.
Yeah, and Ryan, I assume you were studying at that time.
So that was the end of my junior year of college, and the cruel irony is that I was actually at Mississippi State University's Severe Weather Symposium the very minute that all of this was going on. This was sort of the start of the era where everybody had an iPad and radar scope on their iPhone. This wasn't all that long ago. It's been 8 years, but we were kind of in the era of social media. So as these presentations were going on the screen, it's like a mini conference for meteorologists down in the southeast that I was at there and I helped put on. Nobody was paying attention to what was going on the presentation screens. Everybody was tweeting and Facebooking about this situation going on in southern Indiana. And I remember being able to get on Google Maps and measure how far away this EF4, as it was happening, was from my parents' house in Louisville. And it was only 20 miles. And, that made the hair on the back of my neck stick up. And to know what was going on as it was hitting populated towns in southern Indiana, it was unfathomable. And then, of course, I went back to watch the coverage on Wave 3 News after the fact, saw that you guys had, or we at the time had the Storm Chaser video live. That was probably one of the first major situations where you had a live stream of the tornado on the air in this television market in that kind of clarity. Folks were on I-65 shooting video of this live, and this is something that you would generally see out in the plains, but man, to see that here was awful, and I can't imagine what it was like at the station at the time, Kev.
Yeah, I sort of have a hard time talking about it, to be honest, because I think of Lenora Hunter, who lost her husband Wayne. It was the only fatality that happened that day, but the Weather Service did such an admirable job that day with the warnings, and really this had been several weeks unfolding, because that whole week was a tumultuous week with tornadoes down in Hardin County and parts of LaRue County, and that was the leap year. And so we had tornadoes earlier in the week, and then we knew Friday was going to be bad, and we kept stressing and stressing that Friday was going to be a very bad day. You had to pay attention. Our team all came in at 9 a.m. that morning. We've never in the history of Wave Television assembled a whole weather team in a studio at 9 a.m. to get ready for the day. That's just how powerful that day was going to be, and we knew it. So I won't keep going on about it. And Brian, I want to hear your story, but the fact is we were prepared that day. We saved a lot of lives that day. And thinking back at how much worse that day could have panned out sort of brings a little bit of comfort to the job that was done, but it's still a rough day to talk about.
Mm-hmm.
Yeah, and you guys are right. A lot of lives were saved that day. Ryan, you mentioned the fact that we were able to show people on TV the tornado as it was happening. And it's one thing to put out a warning, but if you can show people this tornado and you can show them it's a huge tornado and you can tell them what street it's on, and where it's headed, that's, that is the best thing that you can do. So, yeah, kudos to you all too. I mean, in all the media, everybody did the best that we could that day. My story, I worked, so like you said, it was a Friday. I worked the midnight shift leading up to it. So I got in at 10 p.m. Thursday night and worked till 7 a.m. that morning. And I remember, like you said, I mean, we were looking at parameters and the parameters were screaming. And I remember looking at my partner and we're like, there are no limiting factors. This is going to happen and it's going to be bad. And then, when I left that morning, the warm front was already lifting north and it was already clearing out and we were already getting into the 80s by mid to late morning. And it was like, it wasn't good. And you're supposed to sleep after a midnight shift. And I didn't sleep. I just stayed up and kept watching things and actually went back and helped out on radar later that afternoon then. So, yeah, it's a career day. I hope we don't see anything like that anytime soon. So,
and seeing some of these images, let's just explain to people. So when we talk on TV, oftentimes you'll see both of these images. One shows reflectivity. Those are the brighter colors, the reds, pinks, yellows, greens, a little bit of blue. That's where we can actually, when you talked about the Doppler radar, that beam goes out, it hits the storm, the reflectivity. When it hits something a little stronger, it comes back. So we're looking at that image in terms of the precipitation, perhaps learning about the type of precipitation. And then we see the other screen with the greens and reds, and those are winds. We can also see wind direction and speed with the radar.
Yeah. And again, that's key to helping us identify, where a storm is tornadic versus not. And, that signature that you see right there with the velocity, that's a classic signature. That's the stuff you learn about in school. And, when you see it on the radar screen in real life, it certainly brings it to reality and you're dealing with a serious situation. Another kind of interesting thing you can see is that tornado was picking up so much debris that the debris actually showed up in the reflectivity. If you get those high reflectivities right on the tip of the hook, like you're seeing there on that left screen, then you pretty much know you have a tornado on the ground because that's what you're seeing. And dual polarization radar has really helped us identify debris signatures as well. So yeah, a classic signature there. And that storm, we talked about hail. Those storms both had baseball to softball sized hail in them. There was a supercell that tracked right behind that one that had the softball sized hail. So yeah, even if you're not in the tornadic part of the storm, those things can produce some serious issues from other fronts.
Yeah. Let's talk about the different types of clouds. These are wall clouds. Kind of walk us through. We're going to talk wall clouds versus scud clouds, which can sometimes trip us up, especially if we're spotting. So what to look for?
Yeah. So we talked about the supercell. A wall cloud is going to form at the base of a supercell, that updraft base like we talked about. And again, that precipitation is falling away from that updraft. So a lot of times it's not raining where the wall cloud is or very lightly. And what's happening is that updraft is rotating like we talked about, and that lowers the pressure. And when you lower the pressure, you lower the condensation level. So it actually creates a cloud that hangs down lower. And that cloud starts to rotate, and sometimes it rotates pretty violently, leading up to a tornado. Another thing it's going to do is it's going to pick up lower clouds and bring them up into them, almost like suck them up like a vacuum cleaner. And that, again, if you see that, that's actually another indication that the pressure is lowering, and you want to keep an eye on it because a lot of times if it's sucking up clouds from lower, it's strengthening. The key defining feature that's different from like a shelf cloud, wall clouds are small. They're only going to be like 1 or 2 kilometers in diameter, whereas the shelf cloud, remember, covers your whole horizon. So yeah, you basically want to look for these, and statistics vary, but anywhere from 10 to 15% of wall clouds are going to go on to possibly produce a tornado. So if you see a rotating wall cloud, that's something that we want to know about for sure. That really helps us, when we have a supercell and we're watching it on radar.
And the whole base of that wall cloud would rotate, so it's not just little fingerlings or fringes that are getting sucked up into it that are rotating. It's that whole base that rotates.
Yep. It's like a spinning top.
Yeah. And it's interesting, too. There have been, reports of non-rotating wall clouds in the past on Spotter Network, which, by the way, is kind of an independent thing, not run by the NWS or media here. But Spotter Network just recently took out the ability for storm chasers and storm spotters to report non-rotating wall clouds, which I think is interesting because so many people were misassociating what they would call a non-rotating wall cloud with Scud. And so to take out some of that confusion, now you have to report a wall cloud that's rotating to give you a little bit more fuel to the fire that there may be some trouble.
Gotcha. Yeah. And that's good information. So, because what we get is things called Scud clouds, or we call them scary looking clouds. And a lot of thunderstorms, they produce a lot of weird looking features, and sometimes you get things that look a lot like either a wall cloud or even a funnel clouds at times because they hang down low. And really, the difference between these and a wall cloud and how you'll be able to tell is these won't rotate. So if you see something that looks ominous in that picture right there that you're looking at, I mean, gosh, almost anybody would probably think that's a tornado at first glance. But you just got to stare at it for a second and make sure it's rotating. And, again, look at the ground, see if it's picking up debris. If it's tossing debris, then there's really no doubt about it. But yeah, a lot of times these, the outflow from thunderstorms, you get moisture at the low levels and it creates some weird clouds hanging right on the deck. So, we do get a lot of reports of things that people think look like wall clouds. And hey, you know what? If you want to report it, go ahead. We can still kind of sometimes decipher. But just try to see if it's rotating. That's really the main thing.
All right, let's talk about a little bit of safety. And we've got tornado safety, flood safety, severe thunderstorm safety. Let's start with tornado safety. We say it all the time on TV.
Yeah. And you know what? This is a great time. If you're sitting there, if you're, the kids are out of school right now, so there might be a lot of kids watching. If you're sitting there with your parents and we're talking about weather and storms right now, this is a perfect time to talk with your parents about, storm safety. Hey, where would I go if they issued a tornado warning right now? And the answer is, if you have a basement or a storm cellar, that's going to be your number one place to go, storm shelters. If you don't have that, then you got to get on the lowest floor of your house. You don't want to be on the upper floors because what happens is the first thing that goes is the roof. The next thing that goes are the outer walls. And, what you want to do is you want to put as many walls between you and the outside as possible. So you think about interior closets, bathrooms, pantries, things like that. And another great idea is to put helmets close to your tornado shelter because, flying debris is obviously, you don't want any of that hitting your head and just be able to try to cover yourself up the best you can. So those are some good tips. The other thing is mobile homes. You don't want to be in a mobile home if a tornado is bearing down. I offer virtually no protection.
Zero.
It takes 70 to 80 mile an hour winds and they'll start to roll a mobile home a lot of times. And, once that starts to roll, you're just along for the ride and your chances of getting, injured or worse are, go up pretty dramatically.
And let's face it, the tornado warning as it comes out, it doesn't last very long. So it's not like you're going to have to spend hours in your tornado safe place. It's just minutes, and it could save your life. So that's the important part. So many people think of it as an inconvenience or something that, there's too many warnings. We've got to go down there. Fact is, we don't have that many tornado warnings. And the few that we have, the warnings are so great that you have enough time to get there, be prepared, and just wait it out until the warning is over, the storm is passed, and then come on out.
Yeah, that's great advice. And there are some community storm shelters, and even if you have a neighbor that's got like a basement or a storm shelter, just ask them, hey, if there's ever a situation, can we come over, too? Obviously anybody's going to let you give yourself a chance to be out of harm's way. So So yeah, just think about, if you don't have a place to go, think about where you would go. And then finally, cars, that's the situation you don't want to be in either, in a car with a tornado bearing down on you. So it's not going to offer you any protection either. So just keep that in mind. And that's why we need to be aware before warnings are issued too, really. Be aware of what you might be driving into, So tornadoes and severe weather in general get a lot of play, but the thing we don't want to overlook is that floods, and flash flooding specifically, are actually more deadly on average per year in Indiana and Kentucky. Almost all those deaths are preventable. If you see flooded roadways, we tell people turn around, don't drown. Even if you think it's only a couple inches of water, you have no idea if that road might be washed out underneath that water. Actually, we had a really bad incident that happened up in southeast Indiana a month or so ago where there was a bridge washed out and nobody knew it, and 2 cars drove into it, and I think there were 6 drownings. And so it's not worth it. You got to turn around if you see that. And people just underestimate the power of water in general. I mean, even if you think, oh, my vehicle, I got an SUV, I can drive through that. Flowing water is a dangerous thing, and it is powerful, and you'd be surprised at what it can do, even if you think you're safe. So,
and Brian, I want to underscore what we said last week about this too, especially at night. You cannot see very well, and this is super, super dangerous at night. Yeah.
And that event I talked about, that's actually what happened. It was pre-dawn. The sun hadn't even come up yet, so I'm sure it made things harder to see. So, if it's been raining hard overnight and you're driving to work and it's still dark, kind of pay attention when you cross over bridges and things like that. Just, make sure that bridge is still there, because it can happen. So that's a good point.
Yeah, so flooding, that's the underrated killer. Lightning is dangerous as well. We always talk about severe thunderstorms as well. It's sort of a given if there's a tornado warning, people will find their safe place. But if they hear a little thunder or see flash flooding, they don't pay as close attention. So severe thunderstorm safety, if you hear that thunder, you see the lightning, you got to remember that it's deadly as well.
Yeah. When we go out and talk to schools every once in a while, we'll say, hey kids, when thunder roars, go indoors, and I make them yell it as loud as they can. And you're right. And you brought it up earlier too, Kevin, with supercells. I mean, if you're close enough to hear thunder, you're close enough to be struck by lightning. So, and again, it's just not worth the risk. I know if you're out there mowing and you just want to get that last little bit done, but is it really worth your life? That's the question. And so, just take lightning as seriously as you would any other weather hazard, even if it's not always right there, right in your face. It can be off in the distance. And there's just some simple tips there if you know what to do if you are caught away from shelter. Obviously, you don't want to be up on top of a hill. You'd rather be down in a valley, just because lightning likes to take the path of least resistance. So it's going to try to strike those tallest objects first. So
we talk about golf courses and lakes and pools. It's because that makes you the tallest object. If you're on a golf course, it's typically wide open, so you're the tallest object with a metal pole in your hand. If you're on the lake, you're the tallest object if you're in a boat. So it's about making sure you're not the tallest object. Now, a lot of people would say, well, maybe I stand under a tree. Well, fact is, the tree is the tallest object, but that conducts electricity.
Yep. And we've seen what lightning can do to trees sometimes. One thing I'll say about golf courses is, gosh, over the years, they've really done a good job. A lot of them have lightning detection systems now, and they'll even sound sirens and stuff if lightning gets within a certain radius. And that's great. I would encourage, I'm sure I don't think all golf courses have that, but I would encourage all golf courses if you can get that capability. That's certainly a good tool to have. So
yeah, and that's even in our app, we have the ability for the phone to know your location, and if there's lightning within a 5-mile radius or whatever it is, then it will let you know, and that's important. Make sure you have it turned on.
Yeah, and like you guys said, phones have been a game changer. Smartphones, with the apps that you can get and the alerts and the technology, it really has been a game changer. So it's all been for the positive too. So we're happy about it. Yeah,
let's talk questions for folks that have questions. Brian, tell folks how they can reach you guys.
Yeah, so what I wanted to say was this wasn't our full spotter presentation, but you can actually go online and take the full class and get a certificate and all that. And again, we go out to communities, once this virus goes away. So that's something that is available to you if you're certainly more interested. Lots of good videos and more pics and examples. So there's lots of good ways to receive warnings in that training. Again, we just couldn't cover all that here. So if you want to contact us, through social media is probably one of the best ways. At NWS Louisville is our Twitter feed, and then on Facebook is U.S. National Weather Service, Louisville, Kentucky. If you search that, we'll pop up. So those are the best ways probably to get a hold of us. Now, if you do become a certified spotter, then we actually give you a phone number to call with reports as well. So, and again, when you give us reports, we share those with the media, and when you give them reports, they share them with us. So whoever you get them to whoever you can the quickest, and it's the whole, like we talked about, that whole teamwork thing. The whole team is going to see it. So, and we sure do appreciate it.
Yeah, it makes a difference. Let's take some questions. If you're watching these, you'll know that every Wednesday this month, we've done a Weather Wednesday. We started with the water cycle, how clouds were formed, how the weather really works, how we get that information out to you guys was our second one. The third one last week, we went through and talked about severe weather and the types, whether that's hail, floods, tornadoes, severe thunderstorms. And then, of course, this week we've teamed up with the Weather Service to offer an abbreviated spotter training, so you know what to look for in the sky of what may be severe. So you can view all of these sessions online in our video gallery on wave3.com. Ryan?
All right, let's take some questions from our Facebook folks here. I will get rid of the presentation here so you can see all of us so we can answer your questions. Hello there. And our first question, I just wanted to put out there from Ray, and Ray is asking, so can TV stations have their own radar? Does that run afoul of the National Weather Service having their own radar? And my response to that is, yes, some TV stations do have their own radar. Lexington's a great example. Here in Louisville, not so many anymore, because we have a fantastic National Weather Service radar down in Fort Knox that you folks, Brian, at the National Weather Service operate, and it gives us fantastic coverage in the Louisville television market here.
Yeah, we're fortunate to have a radar so close to the city of Louisville, and we actually have a secondary radar that's operated by the FAA south of the airport down in northern Bullitt County. It's called a TDWR, so it's a terminal Doppler weather radar, and that covers the whole city of Louisville as well. And that radar actually gives us even faster volume scans, so we can see almost minute by minute how that storm is changing. So those two radars being so close to Louisville helps, and they cover pretty much your guys' whole market area. And like I said, you want that radar beam to be pretty low, and I don't think there's anywhere really where the beam is so high that it's not very useful. So we've got pretty good radar coverage in this neck of the woods, which we're very thankful for.
For years, we had our own radar, and we recently, within the last 10 years, sort of dismantled it and got rid of it simply because of the upgrades of the Weather Service radar. As those radars upgraded and we were able to get that data more frequently, we didn't need our own radar as much. So that's been helpful.
And in the last several years, it's updated to where there's new technology that the radar, as it's going up in its vertical rotation, it can come back down in the middle scan to the lowest level and do another slice. So it's not always 5 minutes before we get an update. Sometimes it's a minute and a half, and we'll get a new scan at the bottom. And that kind of goes along with Elizabeth's question here. She wants to know, what's the best tilt on radar scope for spotters to use for a location? And as Brian was mentioning earlier there, the half-degree tilt, the lowest tilt that's available, that's going to be where you want to look if you're a spotter to try to see that rotation, the lowest to the ground.
Yeah.
Go ahead, Kevin. I was just going to say, and you brought up a good point, Kevin, about the volume scans and the minute and a half updates. And you guys talked about those quick spin up tornadoes we get, and that's been a really nice to have those extra little low level scans that we get in between the overall scan. So that was a good point to bring that up.
Yeah, and the thing with the radar is you want it on the lowest tilt because you have to realize the Earth is curved, or so they say.
Depends.
And the radar, as it's fixed, the beam as it goes out will get higher with height. Brian sort of alluded to that earlier, but the farther you get away from the radar, the higher from the surface of the Earth you're going up. So obviously the lowest level, the best. All right, let's see. You have a question there, Ryan?
Yeah, Alicia Willis says, from her daughter Layla, how can you tell the differences between a severe tornado and a tornado that's not severe. And this all has to do with surveying after the fact. We really don't know how bad a tornado is until after it has happened. But there are some clues we can get nowadays. We can see now the debris on radar with those new, what we call dual pole products. And something that's really new that I've been looking into the last couple of years a lot is we can actually see how far up in the atmosphere that debris from a tornado is getting lofted and be able to give you a ballpark estimation of just how violent that tornado can be. So we've got some visual clues from the radar as it's happening, but it's really, Brian, that National Weather Service survey after the fact that gives us that critical rating, wind speed, length, and all of those metrics.
Yeah. So it's funny, a severe weather event, it doesn't just last for, the event. We have the days leading up to it, we have the event itself, and then we have to do the surveys afterwards. And, when you're trying to survey a long tornado path, that can be take quite a long time. I know it took us probably at least a week or more to finish up the March 2nd surveys. And, and then you have to factor in if there's multiple tornadoes, there's several places you have to go. So, yeah. So what we're looking at, while we're going out is basically, the Fujita scale rates tornadoes based on how the wind speeds. And we're looking for how much damage occurred. And, we look for how well built a structure was, and there's certain indicators that basically match up to certain wind speed strengths. So say the roof was missing off the house, then that's generally going to be about an EF2 strength. Now, when you start to collapse a sidewall or two, then you're starting to get into the EF3 range. And then, when you start to wipe that foundation clean, you're looking for, EF4, EF5. So yeah, and sometimes it's hard to tell between tornadic and straight line winds. Straight line winds can do as much damage as a weak tornado. And so what we're looking for with straight line winds is more of a divergent pattern. A lot of times that damage will lay down flat and then spread out, in a divergent pattern. With a tornado, the winds are rotating counterclockwise, so you actually get convergent. You get trees laying in all different directions. So lots of things that we look at. But yeah, there's definitely a period after the storms where we're still busy trying to determine what happened.
Andrew is asking, is there any way to detect updraft speed on the radar?
So one thing we use, and actually this is what, we talked about the low level scan. When we look up at the top of the scan, what we use, if we look at velocity up there, sometimes you can see what we call storm top divergence. So if you remember when we talked about that updraft gets to the top, up where it spreads out, where the anvil is, we can see that updraft then spread out, and we can actually pick up the velocity that's occurring. And so we've used that as an indicator. Like when you get really strong storm top divergence, then you have a strong updraft. So we can't necessarily, give it an exact number, but, we can a lot of times tell when an updraft is stronger than another. Another thing we use is satellite imagery. We've really upgraded our satellite over the past few years with Ghost 16, and that's given us some really cool stuff. Another thing that we look at that's a good indicator of updraft strength is lightning. When you suddenly see lightning, the amount of lightning strikes jump, that's an indicator that you're getting a strong updraft. So lots of different things that we look at.
Let me jump in with one more question here. Talking about the emergency alert system, and we always say that every home should be equipped with NOAA weather radio. You can have all the other tools, you can have the app, you can have a TV with Wave 3 News and the storm tracking team on, but your first line of defense in severe weather is always going to be the NOAA weather radio.
Yeah, that's right. We refer to it as the smoke alarm for weather. Okay, so if you have a smoke alarm in your house, for fire purposes, a NOAA weather radio is just as important for weather purposes. And we have one in the office, so we know when we hit a warning, that thing goes off immediately. So that's, like you said, that's a great first line of a defense. So yeah, I would recommend everyone, pick up a NOAA weather radio if you don't have one. They're easy to program, and you can find them, just about anywhere. I think, Radio Shack, Kroger, Walmart. So
yeah, all the local Kroger stores should have them. Every storm season, we participate with Midland to offer those in the Kroger stores. And as far as that being a part of the EAS or emergency alert system, you all control that part of it.
Yeah, well, no, we do not set off the sirens. Those are the
not
local
the
emergency
EAS alert.
Okay, yeah. So that basically, anytime we send out a warning, that triggers the EAS activation. And so I know smartphones nowadays are programmed basically to go off when you have a polygon that's over you, or a warning polygon. It'll basically trigger your phone. So yes, we set those off, and those trigger the siren, the outdoor sirens, because basically then emergency managers will see that a warning's been issued, and they will trigger it if it's a tornado warning. Some do for severe thunderstorm warnings. If it's a higher end severe thunderstorm warning, that's their local decision, but yeah.
Yeah, and that is a source of confusion, too, because it seems like there's a handful of communities that will trigger the sirens for, just a severe thunderstorm warning versus a tornado warning. Anyway, a topic for another day, but boy, that's confusing.
Yeah. Yeah, we run into it about every year. It seems like we get a question or two about that, so.
Yeah. Justin?
Bethany has a question. She said she always hears people say tornadoes are less likely to touch down in hilly areas. Is that true? No, because if we look back on March 2nd, 2012, that day there were tons of large tornadoes that went through the mountains of eastern Kentucky more specifically. So that is false.
And while we're debunking rumors, the other one is people say the bend in the river a lot of times, will keep tornadoes away, and we know that's not true. April 3rd, 1974, the super outbreak, the Brandenburg tornado crossed the river, and I think there was another one that crossed up near Madison, strong to violent tornado. So yeah, rivers play no factor in it either. If that tornado's strong enough, it's going to go where it wants to. So.
Wait a minute. So you're saying that the Ohio River does not control our weather?
That's what the latest research shows anyway. So
okay, yeah, good to know. All right, Ryan.
All right, quick one from Cindy here. Cindy asked, does hail always precede a tornado? And the answer is no.
Yeah. Especially when we talk about those brief spin-up tornadoes, right? The linear tornadoes. So a lot of times those updrafts really aren't strong enough to produce, large hail, so we don't see hail a lot of times with those. You can get a tornado without hail in that situation. Now, if it's a full-blown supercell, it's probably going to have some hail with it, and depending on which direction that's moving, you're probably going to get a little hail with that before you get the tornado. But overall, the answer is no, not always.
So much of that depends on the thermal profile of the atmosphere too, is what's melting. I mean, all thunderstorms at some point contain hail. It's just a matter of if we see it on the ground.
Yeah. If it doesn't get big enough aloft, then it's going to melt before it gets to the ground. So yeah, and if that updraft's not strong enough to hold up the really big hailstones, that's another reason why it's going to melt probably before it gets to the ground.
And sort of the proof in the pudding of this was the Churchill Downs tornado in 2011. I mean, that was basically a rain shower with a mesocyclone, and it didn't have any lightning. Definitely wasn't going to have any hail. So tornado can be kind of its own thing, and it doesn't have to have even lightning in a storm. Then it's really not a storm, I guess, a thunderstorm to be produced.
Yeah. There's been times where we've sent out statements for like a severe thunder shower, and it says severe thunderstorm in the warning, but there's no lightning, and it's like, though I think those tops on that storm on the Churchill Downs day were maybe like 25,000 feet, and those pictures we were showing you earlier, those are storm tops of 50,000 feet, of what a normal thunderstorm gets up to. So, those were really shallow, and we get that a lot of time in the cool season. So, we always say, the main tornado season is obviously in the spring, but you can get a tornado any time of the month around here. And a lot of times in those cooler months like November, December, January, you'll get those really shallow storms, and like you talked about there. So that's a good point.
Right, and you're obviously not always going to be able to see them. Sometimes they're going to be rain wrapped. So that's why don't go outside trying to look for these.
Yep.
Justin from Wright Elementary says, how do you tell the difference of a downburst and a tornado?
So that's a really good question, and kind of hit on it a little bit earlier with when we talked about divergent patterns. So if you remember right, when we showed that downburst, think about that as like the garden hose, right? And that basically all that water is coming down and it's hitting the ground and it's spreading out. So if we're looking for damage patterns for a downburst, all your trees are going to be laying kind of in a divergent pattern, or what I mean by that is they're going to be spreading out from each other. Whereas if it was a tornadic signature, if a tornado produced the damage, those trees are going to be twisted and mangled and laying in all different directions. And a lot of times what we'll do is we'll try to get an aerial perspective if we can. We've had people fly over damage paths and take pictures. Drones have become a thing where emergency managers, if they have a drone, they're given that aerial perspective. I know the helicopter, we get aerial shots from helicopters. And so it really gives you a different perspective from being on the ground. And a lot of times you can go places where you couldn't go on foot. If it's back in some, forest somewhere, it gets pretty hard to get back there on foot. So, yeah, lots of things we look at, but it's definitely good to have that aerial perspective because you can really see which way the damage is laying.
All right. We'll take a couple more questions. We're going to wrap it up at 2:15, so about 3 more minutes. Ryan, you have one?
Yeah, Debbie's asking, can tornadoes strike the same area? And she goes on to mention a couple areas that may have been struck very close together. And the answer is yes, tornadoes don't really care about specific geography. Tornadoes don't care about dots on a map or county lines. I mean, there's a great example of Moore, Oklahoma. They've been struck like 3 times with almost the same path in the last 25 years, which is just mind-blowing. And we've had a couple of tornado tracks around here that have been pretty close together. So just because you've been hit by a tornado before doesn't mean you're immune from it later. You could have a very similar situation crop up. It's just kind of seemingly random.
Yeah, and to add on to that, not even, just different times of different years or whatever, but even on the same day you could technically get hit by a tornado twice. Just a couple of weeks ago down in the south, there was a tornadic supercell that, was producing a monster tornado, and there was another one that lined up right behind it. And, it was within, I think, 10 miles or maybe even less than 10 miles just north of that original path. And if you think about like first responders going out immediately after the damage starts happening, trying to help people, and then another tornado maybe moving in on top, that's a worst case scenario. So yeah, don't ever let your guard down until Kevin and Ryan and Justin say it's okay to let your guard down.
Well, we saw that in the Henryville storm. That one storm passed by, and then boom, here comes another one with with baseball size hail right behind it. It was terrible.
Yeah, and we were I'll tell you what, we were almost surprised that second supercell on March 2nd didn't also produce a tornado, because it looked just as good from a structure standpoint, and it was in the same environment. So yeah, we were almost kind of baffled that there wasn't a second tornado. Glad there wasn't, obviously, but
sure.
Yeah.
All right.
There's a question here. Lieutenant Colonel Mike Bryant actually wants to know what our favorite weather apps are. So my favorite, I'll start, is Radar Scope. Ryan was talking about that a little bit earlier, because there's everything imaginable that a meteorologist wants to look at, or a storm spotter. You can look at the debris signature as we're looking at correlation coefficient. You can look at reflectivity, velocity, all of it.
Yeah, and hats off to the Civil Air Patrol, too, from Mike there. Now, I'll ask the question again. What's your favorite weather app, Justin?
Radar Scope.
I'll ask it one more time.
Oh, the Wave 3 weather app, yes. Yes. Wave 3. I do have that on both of my phones, work and personal phone.
I am so kidding you.
I know, but
we probably all have Radar Scope on our phones. So it is super helpful. It is a great tool. I'm just teasing.
But with our app, though, I'll be in the kitchen or somewhere in the house, and all of a sudden I'll hear Kevin's voice saying, lightning's been detected in your area. And it's like, wait a minute, for a second, it's like, where's Kevin at?
Do you
get away from it?
Yeah. Do you have a different app that you use, Brian?
I'm going to give the vote for Radar Scope too, and I think pretty much everybody in our office has it as well. As far as radar goes, yeah, and it's the best. It's the best, thing that I can think of. And yeah, Wave 3 weather app. I mean, there's millions of them out there. So, but yeah, it's all good information. So whatever you find that works the best for you.
Exactly. Yeah. All right. Well, we have to wrap things up. We want to say thanks to you, Brian, and John Gordon, and everybody at the Weather Service. We appreciate the partnership that we have to be able to do things like this and all the other things that we do throughout the year to help keep our public safe, and that's the ultimate goal that we all have. So a big thanks.
Yeah, and thanks to you guys again. This was really enjoyable. I love doing this, and maybe we'll find another opportunity to do this again sometime. So, but love the partnership, and yeah, it's been a real pleasure. So thank you.
Well, for folks that are looking for the video, Ryan, tell them how they can find this and all the others.
Yeah, so this video will be available as a recording on the Wave 3 News, the Wave 3 weather pages. We've shared it to our page as well, so just scroll down to find it. It's also going to be on wave3.com, and later today you'll be able to view this recording underneath the weather section of our Roku, our Amazon Fire, and our Apple TV apps, as well as the Wave 3 News weather app. So you can find that on those apps. You can find it on wave3.com. Click weather, then you'll see the education link kind of at the top there. You'll find it there too. So many ways to find it. We'll be posting a link to this as well, Kevin. So everybody should be able to find it on social media.
All right, we'll say goodbye for now. I see the radar in front of me. We do have a few more showers this afternoon before they end. I'll have an update on that coming up after Governor Holcomb. He's on at 3. We'll be on with Wave 3 News at 3:30. And we'll see you then. Have a great day, everybody.
See ya.